For section 5.1, we're going to look at your monomial properties and how we can use those properties to simplify exponents. Now, the first thing that we need to address is how to tell when you're done. How to tell when you're done simplifying monomials is you need all like terms together, so all numbers with numbers, all x's with x's, all y's with y's, and you want no negative exponents. You always want to leave your answer with positive exponents. So all like terms together, no negative exponents. That's how you know you're done. So the first property I want to talk about is how to multiply exponents. So as you can see up here from my example, when you multiply two like bases, so both of these have an a, so they're considered a like base, you keep that like base, you just carry it over, don't change it, but what you do to the exponents is you actually add them. So let's look at a couple examples. So for example, if I gave you 5 to the third times 5 to the 1. Well, 5 to the third times 5 to the 1, you carry over the like base of 5. Don't make it 25, you carry it over. And then the 3 plus the 1 is 5 to the fourth. Let's do it with variables. Let's say I gave you 7 p cubed q times 2 p to the fifth q squared. If I was multiplying these two monomials, the first thing I'd want to do is put numbers with numbers and p's with p's and q's with q's. So the 7 and the 2 aren't like bases. So they're not like bases up here like the 5. So I just multiply them like normal. So 7 times 2 is 14. When I'm putting my p's together, I add those exponents. P cubed times p to the fifth would be p to the eighth. We're adding. And then, of course, when I put my q's together, this is q to the 1. This is q squared. That becomes q cubed, so 14 p to the eighth q cubed. Okay, let's talk about zero exponents. Well, anything raised to the 0 power is 1. Anything raised to the 0 power is 1. So, for example, 6 to the 0 power, well, that's 1. Now, let me make this slightly more complicated for you. In this particular case, we actually have order of operations going on. You need to do your exponent first and completely ignore that negative to the outside. Well, negative 6 to the 0 is 1. Then you would bring over this negative sign. So the answer to this is actually negative 1. So you got to kind of follow your order of operations. Look at this example. 5 to the 0 plus 12 to the 0. Well, that's not 1. This is 1 by itself. The 12 to the 0 is 1 by itself. The answer to this is actually 2. So any separate term raised to the 0 power is 1 by itself. Okay, negative exponents. I told you never to end a problem with negative exponents, so what I need to do now is make sure that you know how to get rid of a negative exponent when you have it. When you have a negative exponent and you need to get rid of it, basically you move it to the opposite side of a fraction. For example, this a to the negative n is in the top of a fraction. It's over 1. To make it a to the positive n, I move it to the bottom. Same thing over here. This a to the negative n is in the bottom of a fraction. To make it positive, I move it to the top of the fraction. So you just move it to the opposite side of the fraction. So let's take a look at a problem. Let's look at a to the negative 2b cubed over b to the negative 1 a. Now the first thing that I notice is not everything has a negative exponent, so not everything's going to need to be moved. This a to the negative 2 needs to be moved. This b to the negative 1 needs to be moved, but this guy right here is positive. It's b cubed, he's positive, so he's fine staying where he's at. And this a to the 1 is positive, so he's fine staying where he's at. So I'm going to keep that b cubed up in the top, and I'm going to keep that a down in the bottom. It's these guys that I need to move. So this a to the negative 2, I'm actually going to move it to the bottom. And the minute I move it to the bottom, it's a to the positive 2. This b to the negative 1, I'm actually going to move it to the top. And the minute I move it to the top, it becomes b to the positive 1. Now, I'm not finished. My like terms are not together. I need to put b's with b's and a's with a's. So I need to finish this. This is in essence b cubed times b to the first. And remember, when we got to switch gears here. When we multiply like bases, we actually add exponents. So that becomes b to the fourth. And then same thing down here. This is a times. So we have a to the 1 times a squared. So this becomes a cubed. All my like terms are together. No negative exponents. This would be my final answer. All right, let's look at dividing exponents. In other words, how do you put like bases together when they're on top and bottom of a fraction? When you need to put like bases together that are on top and bottom of a fraction, you actually subtract the exponents. So when we multiply like bases, we add the exponents, and when we divide like bases, we subtract the exponents. So for example, if I have p to the 6 over p squared, I need to put those p's together, but they're being divided. So what I would do is take p to the 6 minus 2, or p to the 4th. Now the other way to look at this is if you had 6 p's in the numerator and 2 p's in the denominator, which is exactly what this problem over here says, you would cancel them. So you'd cancel and cancel, and you're left with p to the 4 in the top. So there's actually two different ways that you can look at this, but that's how you divide like bases. Okay, last but not least is power to power. What we're going to talk about here is when you have an exponent being raised to an exponent. When you have an exponent being raised to an exponent, you actually multiply those. So if you look at this example, p to the 8 cubed, you would actually just multiply that in. That'd be p to the 24th. Now if you look over here at my second example, when you have multiple bases in a parentheses being raised to an exponent, you actually have to give it to every single base. So let's say, for example, I have 7x squared cubed. I not only would make that x to the 6th, but I also have to give that cubed to the 7, making it 7 cubed. You can't skip the 7. You've got to give this exponent to everything in the parentheses to finish that problem out, or to put all your like bases together. Okay, for our last piece of notes, what happens when it's all together? I want to talk about what to do if it's all together. So the first thing you want to do is get rid of parentheses. Anytime that you're given parentheses, get rid of those first, whatever that means. And then what you want to do is make your negative exponents positive. So when you're given a whole bunch of different rules or things to do, this is the order in which you should do them in. Then you want to do any multiplication. Then you want to do any adding or subtracting, which we don't see much of. And then last but not least, you divide. So when given multiple opportunities, this is the order in which you want to do. For our next example, I'm going to put it all together. All right, take this problem. 4a to the 5th times a to the negative 1 cubed over a to the negative 2 to the negative 2. So we've got a lot of things going on here, and we need to simplify this. So we need to put all numbers with numbers and all a's with a's, and we also need to make sure we have all positive exponents. That's a lot to do. So if you look back at the last slide, the first thing I said was get rid of all parentheses. So the first thing you'd want to do in this case is multiply those in so we can get rid of those parentheses. So once we multiply those in and get rid of those parentheses, what we end up having in the numerator is 4a to the 5th times a to the negative 3 over a to the positive 4. Now, the second thing that I told you in my rules after you got rid of parentheses was to make your negative exponents positive. And I actually only have one negative exponent that needs to be made positive. So this a to the negative 3 needs to be moved into the bottom. Everything else is going to stay. So the 4a to the 5th is going to be fine in the top, and that a to the 4th is going to stay in the bottom. The only guy that moves is that negative 3, and he goes down as a positive 3. Now the next thing that I told you to do was do any multiplication. So my multiplication happens to be right here in the denominator. I need to go ahead and put those together. So 4a to the 5th stays in the top, and that actually becomes a to the 7th in the bottom because we put those together by adding the exponents. Now, I know I'm not done because all my a's aren't together yet. My next step is to do any adding and subtracting, and I don't have any adding and subtracting, so last but not least, we're going to divide. In other words, we're going to put these a's together when they're divided. And if you remember correctly, when you put a's together when they're divided, you actually subtract. So I end up with 4a to the 5th minus 7, which ends up being 4a to the negative 2. Now, you and I know that we can't leave this negative 2. We're going to have to fix it and move it to the bottom of a fraction. So my final answer is going to be 4 over a to the positive 2 once we put everything together. No negative exponents, all like terms are together.